Assalamu alaikum warahmatullahi wabarakatuh. Hello Prep 2, how are you today? Today we are going to talk about the main groups in the modern periodic table. But first, let's remember that we have studied in the two previous lessons how to locate the location of an element in the modern periodic table and the graduation of some properties of elements in the modern periodic table. The first group that we are going to study is alkali metals group or group 1A. As we can observe in the following figure, that group 1A is located at the left side of the periodic table, okay? But there is an important note that hydrogen, which has only one electron, and its atomic number is 1, okay, is located at the top of group 1A due to its atomic number, not due to its chemical or physical properties. So it is not, or it doesn't belong to group 1A, which represents alkali metals. Okay? They are good conductors of heat and electricity as they are metals. Most of them have low density, so some of them or most of them float on the surface of water. Okay? They are monovalent elements because they tend to lose the only outermost electron during chemical reaction and change into positive ions. As we can observe in the following figure, which represents the electronic configuration of alkali metals elements group, lithium, sodium, potassium, rubidium, cesium, and francium, which is radioactive element. All of them has only one electron in the outermost energy level, which confirms that they are monovalent elements. The chemical reaction of alkali metals with water. The reaction with water is a very active reaction, okay, because they are very active metals. So they replace hydrogen in water molecule and form basics with water. Okay, as we will observe in the following video, the reaction of sodium with water. Okay, physical properties of sodium and its reaction with water. First, let's mention an important note that sodium and potassium are kept under the surface of kerosene as they are very active element. Okay. So to prevent the reaction with oxygen, which is present in the atmosphere, okay, they are kept under the surface of kerosene or in paraffin oil, as they are very active metals, okay. First, we will get a part of sodium, which is kept under the surface of kerosene, and we will cut it. We will get first a small piece of sodium by cutting it. Then we can observe that it is malleable, okay, malleable metal, so it can be easily cut using a knife, okay. Then we will put it inside a beaker containing water. We can observe that the reaction of sodium with water. Sodium replaces hydrogen gas, which evolves, and the base of sodium moves heavily as it is very active metal. If we put a larger base of sodium and collect some hydrogen gas which evolves from the reaction, and we test it using a burning candle, we will observe that burning with a pop sound occurs due to the high reactivity of sodium. So it replaces hydrogen gas and water molecule. Halogen group is the second group that we are going to study. or 7A group, as we can observe in the following figure, which represents the modern periodic table. Halogens group or 7A group is located at the right side of the modern periodic table. They have different physical states, as fluorine and chlorine are present in gaseous state, while bromine is located in liquid state, while iodine is located in solid state. They are monovalent elements because they tend to gain only one electron to complete their outermost energy level with 8 electrons during chemical reaction. They don't exist in nature in elementary state, okay, as they are very active elements, okay. So they react with metals forming salts, as we can observe in the form equation, which represents the reaction between potassium and chlorine, forming potassium chloride salt. Inner gases, the last group that we are going to study, they are located at the maximum side of the modern periodic table, as we can observe in the last slide. They are located at the last side of the modern periodic table. This is the zero group or inner gas group. So they are located at the maximum side of the modern periodic table. They are the last group of P block, okay. General properties of inner gas. They are present in gaseous state. All of them are gases, okay. Their outermost energy level is completely filled with 8 electrons, except helium, which has only 2 electrons in its outermost energy level, because its atomic number is 2. It exists in monoatomic molecules, as we can observe in the following figure, which represents the molecule of argon gas. It consists of only one atom. Because they are completely stable, so they don't react even with themselves, okay? The electronic structure or the electronic configuration of argon gas, it represents that it has 8 electrons in its outermost energy levels. The last part of our lesson is some uses of some elements. The first one is sodium, which is a metal. So it is good conductor of heat. So it is used in transferring energy, heat energy, in nuclear reactor from the inner side of the nuclear reactor to the outer side of the nuclear reactor to get rid of the heat energy, okay. Cobalt-60, which is a radioactive element. It is used in preservation of food. As it is radioactive element, it produces gamma rays, which stops the microbial reproduction, so it can preserve the food from microbes. Silicon, which is metalloid, and its conduction of electricity increases with increasing the temperature. It is used in making silicon slides, which are used in manufacture or industry of electronic devices like the slides of computer or mobile phone. The last element which is used in a liquefied state is nitrogen, which is used in liquefied form or liquefied nitrogen. It is used in preservation of cornea of eye at minus 196 Celsius degree, as it can keep the state of or the cells of cornea of eye in a living state at this temperature. That's all about our lesson today, and I hope to meet you in the next video. Thank you.